All right. Only numbers I remember is that we did every third.
Yes.
So what did we do?
12 through 54.
12 through 54. We're on 2-4 or 2-5.
Yes. 127. Page 127.
Yes. What numbers did you say?
12 through 54.
12 through 54. Number 12 is 3, -2, 2, -1. 15 is somewhere. Where is 15? That's 16. Oh, there it is. 1/2, 2/3, -4 with a multiplicity of 2. 18 is something like -3 to 10, and 6, -2, 1, and 4. What is 18? Why is it a sample answer? Determine an interval with the function must lie. Explain your reasoning. Oh, yeah. Okay, great. Number 20, between -6 and, yeah, I do. That is what I mean. Number 21 is -4 to 7 inclusive. No, and then -2, 5, 1, and 3/2. Then 24 is -3 to 5. And 1 multiplicity of 2, -2 with a multiplicity of 2, and 3. 27, 3 or 1 positive zeros and 1 negative zero. 30, 3 or 1 positive zeros, 2 or 0 negative zeros. 33, flip over in case for some reason they're like on the internet or something. Nope, no comments. They're not there. No viewers. They're not there.
On their way.
Maybe. Hope they didn't get in like a wreck or something. They don't usually come together, I don't think, so who knows. All right, 33. F of x equals x to the fourth plus 4x cubed minus 19x squared minus 106x minus 120. 36. F of x equals x to the fourth minus 4x cubed minus 41x squared plus 80x plus 420. 39. F of x equals x to the fourth minus 6x cubed plus 19x squared plus 36x minus 150. We went through 50 something, 54, yeah? Yeah. What did I just read? 39? Okay.
There's Lynn. And Reese is going to be later tonight.
That's crazy. That's crazy. 42a. G of x equals quantity x minus 4 times quantity x minus 3 times quantity x plus 2 squared. Quantity squared. 42b is g of x equals x minus 4, x minus 3, x plus 2, quantity squared. 42c is 4, 3, -2, multiplicity 2. 45 is not that. 45a is f of x equals x squared minus 4x plus 13 times 4x minus 3 times x minus 4. 45b is 4x minus 3 times x minus 4 times x minus 2 plus 3i times x minus 2 minus 3i. 45c is 3/4, 4, 2 minus 3i and 2 plus 3i. 48a is x plus the square root of 5 times x minus the square root of 5 times x squared plus 36. 48b is x plus the square root of 5, x minus times x minus the square root of 5 times x plus 6i times x minus 6i. 48c is square root of 5 times negative square root of 5 times 6i times negative 6i. 51 is negative 3, negative 2, 1, 3 plus I, 3 minus I. G of x equals x plus 3 times x plus 2 times x minus 1 times x minus 3 plus I times x minus 3 minus I. And 54 is 2 plus the square root of 3 times, no, 2 plus the square root of 3, 2 minus the square root of 3, 3 plus I, 3 minus I. And g of x equals x minus 2 minus the square root of 3 times x minus 2 times the square root of 3 times x minus 3 times times x minus 3 minus I times x minus 3 plus I. What questions do we have from those?
All I want to know is what was the answer to number 12. That's the only one.
Okay, only one that you're gonna whatever.
If I know that one, then I know all the rest.
Okay, number 12 is 3, negative 2, 2, negative 1, 4. Oh no, that's just kidding. That's 13.
Okay, got it.
Okay, great. What other questions do we have from this lesson? 42.
Yeah, one of that's 36, so 42.
Okay. Was it the instructions or the?
Yeah, I don't remember going over this. So you didn't.
Well, sort of.
And we also did go over using given zeros to find all complex zeros in each function. We did do that.
We did do that.
That was like the last thing we did. We like thingies that would like say the big thingies. No, that was writing polynomials. Use the given zeros. That was making the polynomials. I'm not sure.
Minus 3x cubed minus 12x squared plus 20x plus 8, no, 48. So we have to factor it. So what should we do?
Define all the factors.
Find some possible ones, yeah, that's true.
So it's just the multiples of 48, or the
Yeah, what are the factors of 48?
48. 1 and 24. 1, 2, 3, 4. No, 3 is not. 4 is.
3 is.
Yeah, 3 is. Oh, yeah, it is. 3 is. Because 3 is a factor of 12.
Because 4 plus 8 is a fact. It is divisible by 3. You can do 3s and 9. You can do 3s and 9s that way every time. You just add up the digits, and if that is divisible by 3, it's divisible by 3. Did we not know this? Look, you learned something new today. Okay. Anyway, 4.
6, 12, 24. You do double back. And then what are you? We're missing one. Are we? There.
8 is 8 divisible by?
Yeah, it is. Oh, yeah, 8 is in there.
Great.
That makes sense.
We can also do our other things to narrow it down further, right? All right, so how many changes are there? There's 1, 2 changes. So for positive real ones, there's either 2 or 0. G of negative x. X to the 4th plus 3x cubed minus 12x minus 20x plus 48. So there's how many changes? There's 1, 2 changes. So there's either 2 or 0. So there are either 2 positive ones and 2 negative ones and no imaginary ones, or there's 2 and 0 and 2, or there's 0, 2, and 2, right? Which doesn't help a lot.
We could do 0, 0, and 4.
Or 0, yeah, you're right. They could all be imaginary. That's true. That is true. Okay, so those are possibles. We can also narrow it down even further by looking at our calculator and shoving it in there and see which ones we should try, and then we start trying stuff, right?
Yes.
So,
Is that a valid way to do it? Just make a table and then just like chunk stuff in there in the X column, look for Y's.
what?
Yes.
That's what I did for a bunch of these. And it worked.
That's what I did too.
You may be saying something quite intelligent,
What we're
but
saying
I don't even
is
know what
go
you're talking
into
about.
your table and have it set to ask for the independent, and then type those in. And if the y is 0, then that means we got one of the x's. Is that fine way to do it?
Well, yeah, you have to show your work once you find them, but
Yeah, no.
a faster way
So
is to just look at the picture and say, oh, it's about that, and then try it real quick.
That's what we were saying.
No, you're saying something that's taking a lot longer with your table.
I decided to look at all the ones that I like found that were like.
You're adding a step into the process is what you're doing. You're like, I think it's there, and then you did it in the table to confirm it was there, and then did the math to thrice prove. You're just adding a step into the process. Fine, which is fine. So, what are we going to try?
3 and 4.
-2, 3.
Okay, we're going to try 3. Sounds great. So see whether 3 works. 1, -3, -12, 20, 48. Something that is worth noting that is easy to do, and some people will tend to do this, and if this is a mistake that you tend to make, after you do the negative one, after you do this one, scratch it out so you don't accidentally copy the wrong things,
Oh yeah.
right?
The graph is super useful.
Well, that's what I do is I check the graph and then I do what you were saying. It's like with the ones.
Yeah, you're adding a step, which is fine,
I'm
whatever.
combining the two things I was doing.
Yeah.
Yeah, you're adding an extra
And
thing.
I just added an extra.
Well, I like
Great.
doing that because if it's something that's got a weird like.
You're gonna have to do this either way.
Yeah.
No, I know.
Oh.
It's just like if it's 3 halves, I want to know.
Oh,
what it
yeah.
is before I
Well,
divide.
there's not usually 2 of them that are like that close in the fraction,
The
but
thing is, I don't want to have to try this multiple times. I just want to know which
No,
ones
let's
are
give it
correct, so
that
then I can just do it.
9, -27,
This one was really fun.
-7.
Why is that 3 though?
Which one?
0 times 3 is 0.
Oh, yeah. Like, why is this not working?
It still doesn't work.
Yeah, it's so
-24, -4.
3 should work.
3 works.
3 doesn't work unless I made another mistake somewhere.
Did I type it in wrong?
12 times 3 is not 24.
It is not.
Oh, yeah.
It's 36.
It's -36.
There we go. -16, which is -48.
There.
Great. So we found one. 3 works.
4. 4. Oh, yeah, 4 works.
4 also supposedly works.
4.
So 1, 0, and
1, 4, 4, 16, 4, 16, 0. It works. -2 supposedly works. 1, 4, 4, 1, -2, 2, -4 does work. Now we have factored this into g of x equals x minus 3 times x minus 4 times x plus 2 times x. This would be x cubed. This would be x squared. This would be just an x. Okay, yeah. It's x.
reals and 1 negative real. We're missing one.
Yeah, we're missing a negative real.
Yeah, we're missing a negative real still.
Let me expand. Oh, no, it is, there is there, because it's x plus 2 twice.
Yeah, I know.
2 negatives.
That's what I was.
That's the second.
That's we've got that right here.
Answering that, but their question.
Oh, in fact, we could have actually quit doing all this mess here and just factored this one, but
But we're lazy suckers or something.
we got x plus 2 right here. So we got that. So part 1, check. Linear indestructible factors, done.
How can we have 2x+2s?
What do you mean, how can we have 2x plus 2s? Look at the graph.
Why do we?
Because
They're right there.
this is this one.
Yeah, but why is there two?
This one of them is this one, and the other one is this one.
So if we factor that out, the end comes up.
No, you're forgetting what happens each time we go. Like this, we factored it into x minus 3 times x cubed minus 12x minus 16. And then we did it again, and we got x minus 3 times x minus 4 times x squared plus 4x plus 4.
Oh, I get it.
Yeah,
So we're just writing out bottom factor.
yeah. So what we would really actually do is write it like this, right? We wouldn't write it twice. We would do, great. It's factored. We did part A, right? Easy peasy.
I did understand how to do that part. It was the rest of the instructions.
And then list all the zeros.
Yep.
What are the zeros?
The zeros are 3, 4, -2.
That's some weird ways of saying it.
Yeah, they just really explained it wildly.
No, y'all are just goobers and forgot how to read English.
The product.
I don't do
Linear
I don't do
factors.
English.
I don't do English well. I do math.
And the product.
I don't do linear factors.
What does linear mean?
Line.
Line. What is the degree of a linear function?
0. No, 1.
1.
That one is a degree of 2.
No, it doesn't.
It's not. What? Because it's square. Oh wait, no, because the x isn't. Idiot. Or not.
So, like I was saying, yes, we did go over this.
We did go over it, it's just the instructions confused me entirely.
Good.
Agreed.
Agreed. Agreed.
You forgot to common sense. It's okay.
I was also doing this
Welcome
in the
back.
library. Well, I was probably like maybe a little bit sick.
Oh,
You were
yeah.
doing it at the library?
Yeah.
That's crazy. Which library?
I think it was on 19th Street. Yeah, it was by LCU.
That's Patterson.
Yeah, that's what it was called.
Why are you doing you work
Because somebody was in our house, my mom was like, we have to leave for 3 hours.
Okay.
I was like, okay.
Any other questions from this lesson?
54. Yeah, that was
54.
How are you doing?
Not saying like
That's what that was. What do you got? 5, 4. Can't even open it, David. Let me help you.
You know what's funny? It just dawned on me that lilt, that musical phrase that is going with 6, 7, that existed earlier than 6, 7.
What?
People, and it may have even been before this, but people for quite a while were saying 21.
Oh, yeah.
It's the same.
I don't remember. It was some little kid, and some kid at my job, he goes, what's 12 plus 10? 21. I was like, what?
I forgot
And
about
he was
that
like,
one.
you were not born whenever that was a thing.
We were. It was
Yeah, but
we
we
were in like
we just
fourth
didn't,
grade.
yeah, we were being sheltered by our parents, or at least I was.
I was still in public school at that time, so I
So
remember
was I.
saying that. I just forgot about it entirely. Why are you taking my stuff?
Look at the boldness difference
I
between
know, I
these two
like that
types.
I can't stand yours. Annoying.
Use the given zero to find all the complex zeros of each function. Then write the linear factorization of the function. Great.
We did one of these, but I forgot how to do it, and I didn't really want to watch the video.
So something you have to understand in pre-cal
is your tool belt is very large.
Yeah.
Is very large, and you have all the tools, and so sometimes you're going to have to go back to that geometry part of your brain and think. I know, thinking's hard,
You know I know.
but you got this. You're going to have to be able to pull these tools and use them in different contexts, especially on homework. Especially homework. It'll get more and more easy as we work our way up the ladder to quizzes and then to tests. But especially on homework, you got to use your brains. We're supposed to factor this, right?
We're supposed to find all the complex zeros of
Yeah.
each function.
And factor it.
Write the linear factorization of the
Yeah, so we're supposed to factor it. So you could start with doing the complex zeros, that's fine. I'd start with the other ones. And cross our fingers that both they're not all complex, because otherwise we're wasting a bit of time. But you can tell that just by looking at the graph. Right? So look at the graph real quick, and if it ever crosses the x-axis, there's some real ones. Right? So start with that.
It seems kind of strange.
I guess it wouldn't
Complex
sometimes.
ones, because they can go like the
Mhm.
x-axis.
Even degree ones and can. Odd degree ones will always cross at least once.
Don't even matter.
Doesn't even matter. 1, 2, 3, 4. Yeah.
Oh yeah, the factors of 10 over x or a.
Ooh, there is real ones.
Yeah. So there are real ones. So we'll go about our normal process to factoring it. So let's figure out what's possible. 1, 2, 5, or 10.
5.
Plus or minus on all of those, of course. So you want me to try 5? Let's try 5. Put your calculators down. Put them down. Put them down.
Why isn't it?
Put them down!
It's not actually going through 5 though on my calculator.
It looks like it's going through 4. Sort of.
It's like going through 4 and 3/4.
So it might not be, well, it can't be. No, it's got to be, because that's a 1.
It wasn't 1.
Let's try 5, see what happens. Don't use your calculators as a crutch.
I don't like crunches. It would probably break.
No way.
No way. Okay. 1, 5, -5, -25, 10. Stop me if I get something wrong. 5 times 10 is 50, which is not what I wrote. 50.
Well, you just wrote 18.
I didn't write 18, I wrote 50.
I don't know what you wrote.
I started to write 15 on accident. Now this is what, 4, 20. Oh, you led me down a sad road. This didn't work.
There are no real zeros.
What?
There are no real
Does it cross the x-axis?
Yes.
There's real zeros.
Not with the things we have.
Does it cross? There are no rational zeros, maybe.
Well, because it doesn't cross at 1 or -1 or 2 or -2 or 5 or -5 or 10 or -10.
As far as you can tell.
No, in the table it doesn't.
On the table, it doesn't. Or y'all are dumb. Oh no. What can we do now?
I don't know.
We should just give up.
No, we shouldn't give up. We should not do that. We got to get this down to something that we can deal with. We're given a factor. What can we do with that? What tools can we pull out of our tool belt for that?
You can probably chunk it in somewhere or something like that.
Some equation words.
Some equation.
I'm also going to throw out there, boys, that if you would have just like looked across the page at example 8, that could have given you some clues, right? Y'all are usually better about that.
Oh, we're doing the same thing except irrational.
So they did it with synthetic division. I don't know whether I think that that's easier or harder. to think about it with synthetic. We can try with synthetic. We can do it with long division. We'll give it a shot with synthetic. Because remember, if it is a factor, and it is a factor, it'll get 0 at the end, right?
Yes.
It will also give us a depreciated equation that we can use, right? Which we make in factor. Or more likely, the quadratic formula, right? If it isn't a rational 0. This is why this one's harder than some of the other ones. The other ones in that chunk. What other one did we do? Did we do 51?
50.
Oh, just kidding. 51's the same. Same difficulty. Same. I just forgot to look across the page. Okay, let's go. Here we go. 1, negative 10, 35, negative 46, 10. Put a line.
You can't do it with 10.
Bring down a 1. Now what?
Multiply by 3 plus I.
3 plus I times 1 is 3 plus I.
Negative 7 plus I.
Is that how
Is that how
that works?
that works?
Let me look.
Sounds about right, right?
Look. Yes, that is right.
Yeah. Because the I's, the I is a number, right? Square root of negative 1, but you can still just treat it like a variable, right?
Yeah.
Same. Like same way we can treat like square root of 3 like a variable, right? So negative 7 plus I
Times 3 plus I?
times 3 plus I.
Wait, that makes I squared.
It is going to make an I squared.
But it also makes I's.
Also makes some I's. Oh no.
Not I.
Negative 21
I squared.
minus 4I
Wait.
Minus 1.
minus 1.
So negative 22 minus 4.
Yeah, wait, you follow this one? You were waiting reasonably. You are having a reasonable crash out right now. It's not unreasonable at all. So because you got to FOIL it, right? So 3 times I is 3I. I times negative 7 is negative 7I. Negative 7I plus 3I is negative 4I. Right?
Okay.
Right? So negative 22.
I guess it's just that we skipped steps and I was not prepared for that.
Yeah. That was a very valid crash out. Good job.
That's unusual.
4I. Now what?
Now we got,
Something.
we get like 13 minus 4. Yes, 13 minus 4.
13 minus 4I.
Okay. 29.
3 times 13 is 29.
39. What am I saying?
Yeah, it is 39.
Wait, no, 4I squared.
Yeah, it is. Yeah, what are you saying?
Come on,
39.
Shut up.
39 minus.
I never make mistakes. I don't know what y'all are talking about.
What are you talking about 39?
Plus I? Does that sound right? Did you scratch paper that out right?
No. Because we get negative.
39 minus 4.
We get 13I minus 12I, which is I, right? So you yelled at me for no reason.
I thought it was negative.
That was something that was crash out.
And then we get
Plus 4.
plus 4. Because the sign flips. Because the I squared. So 43 plus I. What do you mean, nuh-uh?
Negative 3 plus I.
Negative 3 plus I. Look, something's gonna happen. What is happening to me? Go away.
Negative 9.
Negative 3 plus I.
Negative 9 minus 1. Negative 10.
Negative 9 plus 1 is negative 10.
Wow.
And it's working.
Surprise! Actually, the surprise is that we didn't make any mistakes, right? We knew it was supposed to work, but the surprise is it really totally did work.
Let's like not use our factored form for the next
Okay, so we not only have 1 0, we have 2. How do we have 2?
Oh, because it's, why can't I use my words?
Plus or
The
minus.
word. What is the word?
The word is.
Oh, because
God,
the
the
plus,
word is the Bible.
it's plus and minus I, right?
The word is.
Yes.
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 So what could we do now?
3 minus I?
3 minus I.
I thought there was a fancy word for that, and I couldn't come up with
So it is the conjugate factor. That is, yes, there is a fancy word for it.
You don't know what that's like. Your mom doesn't trust you enough to do that.
This one is going to be even more fun.
Oh.
No, I'm serious. Because what's going to happen?
Plus and minus, we don't get 9 the first one. Yay.
This one, if we're extremely lucky, is going to be like not complex numbers no more. Because if it is, then we're going to have fun with the quadratic formula.
Well, it is less
It might be. What?
it is less terms. There's one less.
It's less terms.
And the
And if we're really lucky, we're not going to have to shove i's in the quadratic formula. We might, but we'll see what happens.
What we have to do first, we have to put 1 down there.
Whoa!
Yeah.
Whoa, we
I
subtract
can
an I.
champion.
We're subtracting an I from an I.
and we get no I.
We get no I.
We get no I. The I disappeared.
So now you get -4 with no I.
Now what do we do?
Can't see. Now we know. Okay.
I can't see.
-12 minus
plus
4.
plus 4I.
Kill it.
We don't get
Kill the
the I
I
again.
again.
Yay, he died.
1.
1.
Plus 1. He died. He died.
3
Minus 1. I.
I.
And it equals 0. And
That doesn't have to happen on a problem like this. You could get i's down here, then you have to shove i's in the quadratic formula, and all the things are great. Okay, so right now we have
we can't just multiply.
g of x. We can't, what?
Why would we have to use the quadratic formula? Because it's
Well, we could try some of these again, and actually this is the only one, so we could try 1 with that and see if it worked. But we're down to a quadratic now, so we could just, factor it if it's factorable, right? Yeah.
look very.
So we have g of x equals x minus 3 plus I and x minus 3 minus I times x squared minus 4x plus 1. Then we try to factor it and factor this, and we fail miserably because that ain't never going to work. So then we're going to shove that in the quadratic formula, right?
Because we can't. Because it's
Irrational, you were right.
I was going to say imaginary.
Oh yeah,
That's
no.
not the right
The other I word. The other I word. Or plus or minus square root of -4 squared minus 4 times 1 times 1 over 2 times 1. 4 plus or minus the square root of 16 minus 4 over 2. 4 plus or minus the square root of
12. Wait.
yeah, it is 12. I don't know why I'm writing 4.
Yeah, 4. I was like, wait.
12 over 2.
It would be 4 plus or minus.
4 plus or minus 2 times the square root of 3 over 2.
We take away the 2 and get 2 plus or minus the square root of 3.
2 plus or minus the square root of 3. So then, to do the last bit, we need more whiteboard space. Uh-oh, Baschedio. the final factored form would be g of x equals x minus 3 plus I and x minus 3 minus I times x minus 2 plus the square root of 3 times x minus 2 minus the square root of 3.
Wait, is it minus?
It's minus.
It is minus because it's a positive 2. Okay. Yeah. So we got to subtract it. From
Yeah.
The x.
Yeah. Isn't it beautiful?
No.
That's so ugly.
It really, the thing that I've been hitting today is this was not that hard. And you had all the tools, right? You just got to be able to pull the right tools. It's a lot. There's pre-cal is, I've said this before, pre-cal is the closest thing to geometry that you're going to get again in high school. There's a lot of places where you're going to have to use the geometry side of your brain and be able to pull tools to solve problems, which is good.
I put that side of my brain in like revision. It's like,
So that's not a good idea.
exactly.
You're thinking medical, right? Is that what you're thinking?
No, not really.
What are you thinking? Do you have any thoughts right now? Don't have any idea? Don't have any idea right now?
I was thinking of financial advice.
I put it in a coma.
Financial advisor.
And then
Yeah,
thing.
financial advice, business management, and marketing.
Yeah.
Okay. Well, that's fine then.
Not a financial advisor.
Because at some point, at various points since I've known you, you were thinking medical, you were also thinking engineering. And if you're gonna put the geometry side of your brain to bed, then engineering probably shouldn't be one thing you're considering. Medical, it depends on which particular branch of medical. Okay, so let's do the next lesson.
It's something with a P, psychiatrist, pediatrician. It starts with a P. Which one?
What?
I don't
Okay.
know what that was.
Me neither.
Rational functions.
Let's smoke them.
This is another big old thing. This is another example. In fact, most of the lessons in this chapter are this way in pre-cal. This is another example of this lesson is basically a whole unit in Algebra 2. So there's a lot in here. A lot of things that we got to remember. And I don't think, if I'm remembering correctly what I'm doing, I don't think there's really, the one good thing about this one is there aren't really, there's not any, like in the last lesson, it was all the stuff in Algebra 2, but then there's a few things that we never would have done in Algebra 2. This one, we did all of this in Algebra 2 over time. So this is going to be entirely reviewed theoretically. This is fun stuff. Now, I don't know if y'all have started studying for this test yet or not, but you may want to think about it. Because I don't know if you've noticed, but this chapter is chock full of like a crap ton of stuff. There is so much in this chapter to remember. It's multiple chapters of Algebra 2.
Can we have like a review day for this test?
No.
Could you like
I like the review days.
Unit 2
Part A and Part B, no.
Unit 2 part
No.
I want that too. I want
That is not a thing.
a review.
That is not a thing that's going to happen. Okay, so rational function is what we were talking about in this lesson. What does rational mean?
not irrational.
Oh.
It could be expressed as a function.
Thank you. It can be written as a fraction.
It's not irrational.
Okay, it is the shorthand definition. We could go into A's and B's and all the things and whatever else. But yeah, it can be written as a fraction. So a rational function, a reciprocal function, the parent function is f of x equals 1 over x. Right?
See.
What does that parent function look like? Do you remember?
Is it this one?
It's a
No, that's not looking right. This one?
No, that's an absolute value.
Then is it this one?
It's the one that looks like this.
Yeah, it's this one. This one.
Yeah?
It's this one.
I don't know what we're doing. Being strange.
This is what you did in that one
This
lesson.
is what you did in that one
It's
lesson.
so it can look like
That's
this or this.
that's
this,
cubic.
or this.
That's the last chapter. I mean the lesson. These ones are not continuous. These ones have infinite discontinuities. Now, rational functions, so this is a reciprocal function. We split this into two things, but reciprocal function is just the most basic form of a rational function. Okay? So a rational function has a polynomial in the numerator and a polynomial in the denominator. It can, right? So there's some sort of polynomial function in the numerator, some sort of polynomial function in the denominator, right? So there's like a bunch of terms, right? Following me so far?
So far, yeah.
So far, easy peasy.
I think I'm about to get lost.
No, you're not.
About to.
You're not. No, you're not. You're not going to get lost. You're going to write down all the notes, and you're going to ask when you got confused, and then you won't be lost, yeah? Yes, this is notes. We're doing notes in class, and we're going to be doing notes in class for the rest of the year in this class. No, there's no pause button, but actually there is one. It's called your mouth. You can say, wait, what is that? You've already done that once today, and it was great. Grand, glorious, valid crash out. It's good. Don't lose that. Okay.
You gotta keep my valid crash outside.
Okay.
Wait. I use like 30 weights.
Okay. So, there are a few things that can exist. Well, a few variations of this thing.
I did not like this.
Well, maybe you will get it this time.
A
Because you're gonna lock in this time. Asymptotes. Asymptotes, right? Asymptotes. There are three kinds of asymptotes. What's one of them?
A horizontal.
Yeah, horizontal is what. There are horizontal asymptotes.
vertical.
Why is it PDT?
There are vertical asymptotes. And one more.
Triangle.
Yeah, the crossing.
Yeah, so depending on where you look, what is this book called? There are two names that you'll find on the internet. What is this book? What is this book? Yeah, that's what I figured. I figured that this book calls it an oblique asymptote. The other word that you will see often is a slant asymptote.
I like that
So
one
much
better.
nicer. So much nicer.
But the kind of formal name, like the real name, is an oblique asymptote.
Yeah, but also the name for a dog is like, what even is it?
Canine.
No, that's not what it is. It's like caninus something.
So no, that's false. The word for dog is dog. The Latin-derived name is canine, and what you're trying to come up with is the actual Latin name. The name for a dog is dog. The official name for a dog is dog. There are also scientific designations for dogs, which is certainly the Latin name.
That's what he's trying to get at. That would be oblique.
Yeah, like the oblique
Yeah.
is like the
Yeah, great.
slant. It's a freaking dog.
Anyway, those are the types of asymptotes. We need to be able to figure out where the asymptotes are.
Oh, there's the asymptote.
Where's the asymptotes?
Where the things don't go anymore.
What?
Where the things don't go anymore.
Wait, the thingies don't go anymore.
The line doesn't
Okay.
like you go past them.
Yeah.
Vertical asymptotes.
That's a crazy.
Define the vertical asymptote.
Vertical.
Define the vertical asymptotes. Do you remember what you do?
No. That's not too long.
The
Is there not like a
denominator
denominator
can't be 0.
Yeah.
Set it equal to 0.
Set it equal to 0 and solve. Easy peasy. No big dealio. No big dealio at all. I'm sorry, I keep looking at this box. Like It's good, but it's like, if you want to see some formal definitions for what vertical and horizontal asymptotes, you can look at the top of page 131.
I see.
It's not going to help you solve problems, but it is discussing the limits and how the limits go and all the things. If the limit is infinity, it's vertical asymptote. Easy peasy. That's calculus stuff. If the limit is a specific number, if there's a horizontal asymptote there. Great.
Asymptotes is where they can't be like that stuff is zero.
It's going to get closer and closer, but it's never going to get there.
This stuff is like 0 and 0. The first one you drew.
Yes. It has a vertical and a horizontal asymptote. And it has both. Okay, so vertical asymptotes, easy peasy. Set the denominator equal to 0, solve it, there's a vertical asymptote there. Unless it's a hole, but we'll talk about that in a minute. Okay. So, for a horizontal asymptote, we gotta do more things. We often have graphing calculator tie-ins in pre-cal. You can check whether you did the math right, but you're still going to have to show the math to get the credit, right? Because you can figure out where a vertical asymptote is. Well, actually, you can figure out where a horizontal one is too. Slant asymptote would be a little bit trickier to find using the calculator. There probably is a way, but I can't tell you off the top of my head how to find a slant. You can find that there is one, but you can also tell that just by looking at the thing, which we'll get to in a minute. But you can see whether it's a vertical asymptote there by looking at the table, and there's going to be an error or it's broken, right? So you can see whether you did the math right. You can also, one of the nice things about it in pre-cal, and I think y'all have figured this out already, is you can you're kind of carrying around the key that you can double check what you're doing, right? All right, in a lot of things, right? That's as long as you punch it in right. But anyway, so what would you be looking for to figure out where the horizontal asymptote was in the table?
It has to be the same,
It's going to be approaching the same number, right? So you start shoving in big numbers or little numbers or whatever, and if it's getting closer and closer to that thing, that's where it was, and you can check that you did it right. So horizontal asymptotes, there are a few checks. Okay, so the first possible, in order to see which route we're going down, we're looking at the degree of the numerator and the degree of the denominator. Okay, so if the degree of the numerator
degree of numerator is the one on top, right? I just had to make sure. I was sanity checking from out
Yeah,
the pre-cal.
yeah.
I just had to make sure.
If the degree of the numerator is less
Yeah, that was the semi-valid scratch.
than the degree of the denominator, I don't know why I'm turning that into Q all of a sudden, then it has a horizontal asymptote at y equals 0. So like the reciprocal function, what's the degree of the numerator in 1 over x? 0. What's the degree of the denominator? 1. So 0 is less than 1. It has a horizontal asymptote at y equals 0. And if the degree is less on the top than the degree on the bottom, it has 1 there, unless something specific, which we'll get to in a second. Okay? All right. So if they are equal, so the degree of the numerator equals the degree of the denominator, then it has, sorry, I have to sanity check, there's so much in here, has a horizontal asymptote at y equals a sub n over a sub m. I was going to keep from writing this whole thing, but I don't think I can get away with it on this one. So what we're talking about, we've seen this idea in the last chapter. So a sub n is the leading coefficient. All that way to a naught. We won't do all the things.
Oh, wait,
Not always.
I thought that was in.
Oh, yeah. So, and then in the denominator, we use a sub m as the leading coefficient, and x to the m, and then all the way down to a, it'd still be a naught. I don't know, whatever. Probably be easier with a's and b's. What did they use? Oh, they did. Yeah. That makes more sense. How about b sub m? Because it's not the same letter. Down to b naught. That's great. That's a lot easier way to do it. Easier with a's and b's. Well, that's what they did. Anyway.
Learn your A's and B's.
So it has a horizontal asymptote at whatever that number would be, right?
Yeah.
Leading coefficient, numerator over the leading coefficient of the denominator. Make sense? Even though I had a minor crash out in the middle and my brain broke, right?
B of O.
B naught. So that's the last term. That's the constant. It doesn't. We don't need it for what we're.
The leading coefficient of
Yes.
the top and the constant of the bottom.
No. Oh. Oh my gosh.
Leading coefficient of the top.
Yeah, which is what I was saying out loud, but I wrote down the wrong thing. I'm sorry. What if the third option is true? If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote.
It's a slant asymptote instead.
Not necessarily. Well, and no, not at all, actually. But we'll talk about slant asymptotes in a minute. Let's do an example with some things first before we get there. That's kind of funny because that example is a stupid one. Let's do that one. That looks better. Let's do an example.
Stupid. We should do it.
No, it's this one, this example here that they give. Example 2b, they gave one that, if I'm not greatly mistaken, I'm not, as I look at it, has a slant asymptote, but they haven't talked about slant asymptotes till example, I broke my book, till example 4. So, I don't know. Okay. All right, let's do a example. Let's graph. Determine any asymptotes and graph this guy. This is a good one. Let's do n of x equals x over x squared plus x minus 2. Does it have a vertical asymptote? Yes. Does it have a horizontal asymptote?
Yes.
Wait, the degree of the denominator.
Less. Yes.
It does. Where is it?
0.
At 0. So it has a horizontal asymptote at y equals 0. So to find the vertical asymptotes, what do we do?
Set denominator equal to 0.
Set the denominator equal to 0.
So x over 0.
What? Stop. Calm down.
Oh, I thought we were putting the whole thing just like.
No, we gotta figure out.
The denominator equal to 0. x, 2, 1, plus and minus, right? So it has vertical asymptotes at x equals -2 and x equals 1. Has 2 vertical asymptotes, right? Great. Oh, I picked the wrong one. That's funny. That's funny. Because I was looking at that picture and not really thinking about what I was writing. Where's the 3B one? Where's their version of its picture? Oh, there it is. Oh yeah, no. I did good. We're all happy. Great, let's graph the thing.
Yay.
My mother's at work.
So what are we going to do to graph it?
Shove it in our calculator.
No, don't touch your calculator. Not yet.
Okay, so
Use your brain first. What are we going to do?
We gotta know that there's asymptotes in different places.
yeah,
Great.
we can just write the asymptotes in.
We're going to dot in the asymptotes. Gonna dot in one right here. Got to dot in one at -2.
This guy's taking up over 3 tables now.
Yeah, as if someone's gonna sit there.
Someone's trying to sit there.
Okay, there's our asymptotes. We got 3 chunks.
Yay.
So what would we do now to graph it?
Calculate. We're gonna use arrows, and we gotta do like that and like that, don't we?
I have no clue what you just said.
We've gotta draw a line.
If you didn't get a graphing calculator, what would we do next?
I would go back.
Buy a
to
graphing
calculator.
Go find it.
No. What would we do? How can we figure out what it looks like? Because we got like all kinds of options for what can go in here, right? There can be little things that go like this. There can be a thing that goes like this. There can be a thing that goes like this. There can be a thing that goes like this. There can be a thing that goes like this. We don't know. We don't know.
Exactly, we don't know.
We don't know. So how could we know?
Plot some points.
We could plot some points.
Yeah, I forgot about that.
Flipping brilliant, which is what you're going, everything I'm putting on the board, to be clear, this needs to be on your paper in order to I'm not talking about notes. I'm talking about if I gave this to you on a test, everything that I'm putting on the board needs to be on your paper for you to make all the points. Okay, does that make sense?
Yes.
Okay, so what X's would be great to put in here?
Not -0, -1, -3.
0, -1, -1/2, -3. So we've got one over here. We've got one in here. We've got one a little bit in here. 2 would be great. We probably need another one over here, right?
-16.
-16
Let's do 36.
and 36. And then sure, shove it in there and then look at the table and find these things. Ready to go.
Yay, finally.
We do love our graphic calculator.
You don't necessarily have to show how you got all the points. You have to show what you did. You have to pick points that make sense for the graph. You have to show that you understand why and what you're doing. Yeah?
Oh wow, that's a lot of lines.
Holy crap.
That's a lot of lines.
So we need to know where it is at 0. So jump over to your table.
I don't
0
know why I was
is at
already
0.
at 36, but I'm at 36.
It says 0, 0.
0, 0.
Wait, but that doesn't work.
Yes, it does.
Is there not an asymptote there?
No.
You put a 0 in here and you get -2 in the denominator, 0 up here and you get 0. So 0 over -2 is 0.
This is what the graph is.
That one you could have got without
I didn't look
the
at that.
calculator. That one you could have just thought about it.
Whoa, that's exciting.
Yeah, we're about to put it on here. Where is it at -1?
0.5.
Wait, so does the horizontal asymptote doesn't apply to the middle section?
Sometimes it doesn't. Sometimes it'll cross.
Huh. Interesting.
At -3, it says -3.
At 1/2, it's at 0.2222222 repeating.
What is that as a fraction? Should make you go back to middle school and do that by hand.
I don't even remember. Hold on.
It's 22/99, whatever that is. 2 ninths.
Negative.
See, I told
Yeah,
you.
yeah,
I told you.
yeah, 2 ninths.
-3 is -3/4.
2 is 1/2. You do 16, I'll get this.
-0.06, a specific number.
36 is 18,660 bits.
16, -16 makes you mad.
We knew it was going to be approaching 0, right? We mostly needed to know whether it was approaching it from here or from here, right? That's what we knew. That's what we needed to know, right?
And then it's like,
All right. So then we got 0, 0, -1, 1/2, -1/2, 2 ninths, and then -3, -3/4, here-ish. Negative 16. So it's going like this. And then it goes like this. And then it goes like, we only did 2 1/2, but that's fine. Goes like this.
Yeah, that's what Reese's calculator said.
Yeah. And you understand why it says that, right? That's the so you, yeah, anyway. Let's give you a little bit of homework and then get out of here. We're already pushing our time a little bit. Oh my gosh, ripped it worse.
I love sticky notes. Surprisingly useful.
Any of them? That one's a degree of 4. That one's, yeah, probably not. So we're going to do 2 through 18 evens.
I knew it. I knew it.
I don't think, just in my cursory glance, I don't think I see any with a slant asymptote, but
I knew exactly what problems he was going to assign. I could just finally figured it out.
it's almost like it matches what we covered. I mean, like, that's crazy. Who'd have thunk it?
It's also almost like actually, yeah, you're right.
What? It's like the same thing that we. Oh, that's crazy. Go away. Find somebody that loves you. Give them a hug.
My grandparents.
Okay, good. Go give them a hug.